You know, Bitcoin, it's incredible to think that this whole thing started with just a 9-page paper posted on a little-known mailing list. It was this wild idea for money without banks. And now, well, now it's a global asset and it's dealing with big-time finance, government regulations, and its own internal challenges. So how'd we get here? How did a bit of code evolve into a new kind of currency? Let's trace that journey.
Seriously, just stop and think about that for a second. Every single time you pay for something online, a bank or a credit card company is sitting in the middle. They're the gatekeepers. They approve it, they settle it, and yeah, they take their cut. But what if you could just skip them entirely? What if you could send money directly to anyone, anywhere on Earth as simply as you send an email? That's the huge question that Bitcoin was built to answer. And right there, that gets us to the core philosophy of Bitcoin. See, it's not just about creating a new kind of digital dollar. It's about creating a whole new way to trust each other with money. This was the central problem that Satoshi Nakamoto's 2008 white paper tackled head-on. The internet let us share information, sure, but not value. The big stumbling block was this thing called double spending. How do you stop me from sending you a digital coin and then immediately sending that exact same coin to someone else? Without a bank in the middle to keep a master list, it seems impossible. The proposed solution was a massive shift. Let's replace trust in institutions with trust in math, in pure, cold, hard cryptographic proof. This is literally the first sentence of the Bitcoin white paper, and it tells you everything you need to know. Peer-to-peer, direct, no financial institution. That single sentence lays out a system where the middleman just vanishes. But okay, how on earth do you actually build something like that? Well, the answer is a piece of technology we've all heard of by now, the blockchain. It's essentially a giant public book of accounts, a shared history that everyone can see. And crucially, no one can change once something is written down.
And here is the really clever part. A Bitcoin isn't some file that sits on your computer that you can just copy and paste. Nope. A coin is just an entry in this massive public ledger. Its entire history is defined by a chain of past transactions. So when you send a Bitcoin, you're using your unique digital signature to add the next link to that chain, publicly signing over ownership. It creates this perfect, verifiable trail of who owns what.
So how does this whole global network agree on what's true without a CEO or a central server? It runs this ingenious little 6-step dance over and over about every 10 minutes. First, all the new transactions are shouted out across the network. Computers, called nodes, gather them up into a neat little block. Then, the race is on. All these nodes compete to solve a really hard math puzzle. That's the proof of work. The first one to solve it gets to broadcast their block to everyone else. The other nodes quickly check the math, and if it's all good, they add that block to their copy of the chain, and the race starts all over again. It's this constant competition that keeps the whole thing honest.
All right, so that's the big picture of how the network runs. But what about for you, the user? How do you actually use this stuff? Well, let's get practical. It really all boils down to 3 things: mining, wallets, and keys. Okay, this is probably the most critical piece of information for anyone who ever touches Bitcoin. Your quote-unquote wallet doesn't actually hold any coins. It holds your keys. Your public key is like your bank account number or your email address. You can give it out to anyone so they can send you money, no problem. But your private key? Oh man, that's the password. It's the only thing that proves you own the Bitcoin at your address. If someone else gets it, they have your money. If you lose it, your money is gone, forever. It is absolutely everything. So, you might be wondering, why would anyone spend a ton of money on powerful computers and electricity just to solve those math puzzles? Well, there's a huge incentive. The whole process is called mining. And when a miner solves the puzzle and adds the next block to the chain, they get a reward, a bunch of brand new Bitcoin plus all the transaction fees from that block. It's a lot like gold miners using energy to pull gold out of the ground. Bitcoin miners use computer energy to mint new digital money into existence.
And here's one of Bitcoin's most famous and most important features. Unlike government currencies, which can be printed whenever, Bitcoin has a hard-coded limit. There will only ever be 21 million Bitcoin. That's it, full stop. This digital scarcity is what makes it feel more like a commodity, like digital gold, than just another currency. But of course, taking a revolutionary idea from a white paper and making it work for millions of people in the real world, well, that's never a straight line. As Bitcoin got more popular, its own limits started to show. The main Bitcoin blockchain is secure, but it's also kind of slow. It can only handle a handful of transactions every second.
I mean, that's not going to work if everyone's trying to buy their coffee with it, right? So a solution was created called the Lightning Network. Think of it like an express lane built on top of the main highway. It lets people open up direct payment channels for tons of tiny, instant transactions off to the side, and then they settle up on the main blockchain later. But, and there's almost always a but, this clever solution for speed created a new and kind of ironic problem. Because the Lightning Network needs well-funded, well-connected nodes to route all these payments, it has started to become, well, pretty centralized. You've got a few huge hubs that are now handling a massive chunk of all the traffic. And what's so fascinating is how you can see this happening. This chart basically shows that the algorithms designed to make the network reliable by sending payments through the biggest, most liquid nodes have created a rich-get-richer effect. The biggest hubs earn way more in fees, which helps them get even bigger, which means they get even more fees. It's this feedback loop. And it's a real trade-off. In the search for speed and efficiency, a system that was designed to be decentralized starts to develop these powerful central players. So, this evolution from a tiny tech project to a global financial force meant the traditional world just couldn't ignore it anymore. And that brings us to the final part of our story. What happens when this new code clashes with old laws? And things are moving fast. I mean, just look at the UK as an example. A few years ago, crypto was a total legal gray area. Now, there's a full-blown roadmap. By 2025, it's officially property. By 2026, international tax rules kick in. By 2027, a full regulatory system, just like with regular finance, is expected. The message is pretty clear. The Wild West days are coming to a close.
So what does all this mean for you? Well, if you run a crypto business, it's time to get ready for some serious compliance. For individuals, yeah, the tax man is definitely going to be paying more attention. But there's a flip side. Because crypto is now being legally defined as property, it's actually becoming easier for courts to help victims of fraud get their money back using traditional tools like freezing orders. The whole system is growing up.
And all of this brings us full circle, right back to a final really big question. Bitcoin was born from this radical idea of replacing trust in banks with trust in math, with cryptographic proof. But as it gets tangled up in our existing legal and financial systems, you have to ask, is it finding a new kind of balance, taking the best of both worlds? Or is this revolutionary technology slowly but surely being absorbed by the very system it was designed to replace? That right there is the question that will define its future.